Ever wondered how your network data knows exactly where to go in the vast universe of the internet? The answer lies in a fundamental protocol, known as the Border Gateway Protocol, or BGP. Imagine BGP as the GPS of the internet, providing directions to data packets so they can find their way across complex, interconnected networks. It's like the ultimate traffic controller, managing the flow of information to ensure your data reaches its destination efficiently and accurately. The importance of BGP in maintaining the smooth operation of the internet cannot be overstated. It's a key player in the grand scheme of things, shaping how we use and experience the internet every day. Without BGP, we'd be lost in the digital cosmos, struggling to navigate the intricate web of networks. Now that we have set the stage for understanding BGP, let's dive into some common scenarios and questions that come up in interviews related to this protocol. Imagine you're in an interview and they ask you, "Can you explain how to set up a basic BGP configuration?" Well, it's pretty straightforward. Let's dive right in. First, you need to start by entering the global configuration mode on your router. You do this by typing configure terminal into the command line interface. This will allow you to make changes to your router's configuration. Next, you enter router BGP, followed by your autonomous system number. This command will create a new BGP routing process. Remember, the autonomous system number you choose must be unique to your network. Now, you're going to want to specify the networks you wish to advertise. To do this, you use the network command followed by the IP address of the network you're advertising. This command tells your router to include these networks in its BGP updates. But we're not done yet. The next step is to establish a BGP connection with a neighboring router. You do this by typing neighbor, followed by the neighbor's IP address and the remote autonomous system number. This command will establish a BGP session with the specified neighbor. Once you've set up your neighbors, you should verify your BGP configuration. You can do this by using the show IP BGP summary command. This will display a summary of your BGP configuration and provide information about your BGP neighbors. Finally, don't forget to save your configuration changes. You can do this by typing copy running config startup config. This command will save your current configuration to the startup configuration file, ensuring that your changes will persist even if the router restarts. And there you have it, a basic BGP configuration. Remember, practice makes perfect. Now, you've been asked, how does BGP advertise routes? Well, let's dive into it. The Border Gateway Protocol, or BGP, is a protocol that manages how packets are routed across the internet. It does this through a system of route advertising. So how does it work? First, a router configured with BGP will advertise its directly connected networks to its BGP peers. These peers could be other routers within the same autonomous system, known as internal BGP peers, or routers in different autonomous systems, called external BGP peers. To start the advertisement process, you use the command network, followed by the IP address of the network you want to advertise. For instance, network 192.168.1.0. But remember, the router will only advertise networks that are present in its routing table. Once the network command is issued, the router will send out an update message to its BGP peers. This update message contains the network's prefix and the path of autonomous systems the update has passed through. Now, when a BGP peer receives this update message, it adds the network to its BGP table and then advertises it to its own peers. This is how BGP spreads the word about the best path to a network. But what happens if there are multiple paths to a network? BGP has a solution for that too. It uses a system of attributes to determine the best path. The most preferred path, according to BGP's path selection process, is then inserted into the routing table and advertised to peers. This entire process is continuous and dynamic. As routers receive new information about networks, they update their tables and advertise the changes to their peers. But remember, BGP is a complex protocol that requires careful configuration to ensure network stability and efficiency. So, when working with BGP, it's essential to understand its mechanisms and how they influence the flow of traffic across the network. And that's how BGP advertises routes. It's all about spreading the word to neighboring routers. What if your interviewer asks, how does BGP select its path? This question takes us into the heart of the Border Gateway Protocol. The path selection process in BGP is like a meticulous treasure hunt, where the treasure is the most efficient route for network data. BGP uses a set of parameters or attributes to determine the best path for data. These attributes are the key players in the path selection game. They include weight, local preference, locally originated routes, as path, origin type, and MED, among others. Let's break it down. The first attribute BGP considers is weight. This is a Cisco-specific attribute and isn't exchanged between routers. The path with the highest weight is preferred. If paths have equal weight, BGP moves on to the next attribute. That next attribute is local preference. This one is exchanged within an autonomous system but not between systems. Again, the highest value wins. Locally originated routes come into play if paths have equal local preference. BGP prefers routes that are locally originated via a network or aggregate BGP subcommand or redistributed from an IGP. If all these are equal, BGP looks at the AS path attribute. The path with the shortest autonomous system path is selected. Next in line is the origin type. If the AS paths are the same length, BGP will consider the origin attribute. The preference order here is IGP over EGP and EGP over incomplete. The MED or multi-exit discriminator is the next attribute. It's the tiebreaker if the origin type is the same. The path with the lowest MED value is preferred. And if all these attributes are equal, BGP will finally consider the oldest path for stability. So, you see, BGP path selection is a layered process. It's like navigating a maze, with each attribute serving as a guidepost to the most efficient path. So that's the process of BGP path selection. It's all about choosing the best route for your network data to take. The next question is, what is route aggregation in BGP and how does it work? Route aggregation, also known as route summarization, is a method used in BGP to combine several routes into a single route. This is done to reduce the size of the routing table and simplify the network's complexity. Imagine a scenario where you're at a crowded party and you're trying to find your friend. You could either ask each individual if they've seen your friend, or you could ask a group of people if they've seen your friend. The second method is more efficient, isn't it? That's essentially how route aggregation works. Instead of having numerous routes to different networks, you can aggregate them into a single route. Let's delve a little deeper. BGP, being an internet protocol, uses IP addresses. These addresses are often presented in a slash notation, like 192, 0.2, 0.24. The number after the slash represents the number of bits that are the same for all addresses in this network. When we aggregate routes, we're essentially finding a common bit pattern in the network part of the address, and representing multiple networks with a single, more general address. To implement this in BGP, we use the aggregate address command. For instance, let's say we have the networks 192, 0.2, 0.24, and 192, 0.3, 0.24. We could aggregate these networks into a single network, 192, 0.2, 0.23. This would be implemented with the command aggregate address 192.0.2.0.255.255.254.0a. Keep in mind, route aggregation must be used judiciously. While it simplifies the routing table, it can also lead to less specific routing, which may not always be desirable. It's a bit like asking a group of people at the party about your friend rather than individuals. You might get a general direction, but you might miss out on specific information. That's an overview of route aggregation in BGP. It's all about simplifying the internet's complexity. Finally, they ask you, how would you troubleshoot a BGP issue? The key here is to approach the problem systematically. Start by verifying the basic BGP configuration using the show IP BGP summary command. This will provide you with an overview of the BGP neighbors and the routes being advertised. If there are issues with the neighbors, use the show IP BGP neighbors command to check the details. If you spot any irregularities, it could be due to incorrect configurations or network connectivity issues. Next, verify the BGP routes using the show IP BGP command. If the expected routes are missing, you may need to look into the route advertisement or path selection process. Lastly, if the issue persists, you may want to debug BGP using the debug IP BGP command. But be cautious, as this can generate a lot of output and may impact the router's performance. And that's how you troubleshoot a BGP issue. Remember, it's all about understanding the problem and knowing the right tools to use. And there you have it. We've delved deep into the realm of border gateway protocol, unraveling the mysteries that often perplex network engineers. We started off with the basics, understanding the fundamental configuration of BGP. Then, we navigated through the process of BGP route advertisement, revealing how information is propagated across networks. Our journey then took us to BGP path selection, where we discovered how BGP chooses the best path among multiple available options. Following that, we explored the concept of BGP route aggregation, gaining insights into how BGP efficiently manages a vast number of routes. Lastly, we tackled BGP troubleshooting, arming ourselves with the skills to diagnose and resolve common BGP issues. It's been quite the deep dive, but remember, this is just the tip of the iceberg. Understanding BGP is a fundamental part of being a successful network engineer. So keep learning, keep practicing, and you'll be answering these interview questions with ease in no time.